Hi guys. Okay, I am out today, so I have made this video to just kind of go over the attributes and the transformations of the square root functions. The first thing that I want you to make note of is the square root parent function. That is y equals the square root of x, where x is greater than or equal to 0. Reason that we need the x to be greater than or equal to 0 is because if it is a negative number, then it will end up giving us an imaginary number, as we learned when we were working with complex numbers in the quadratic formula. Okay, now the full function formula with our a, b, h, and k in it is y equals plus or minus a times the square root of plus or minus bx minus h, and then outside of the square root symbol plus k. Okay, make sure you get that all written down into your notes. Okay? Alright. Let's take a look at the graph of the parent function. Okay, so again we said y equals the square root of x, where x is a positive number or 0. Again, I wrote down there the note. Why? Because if it's negative, we get into imaginary numbers. Okay? Also, I want you to note that we only graph the positive side of the square root. That is because there is not a negative sign in front of it. It doesn't say plus or minus in front of it. It just has no sign. That means it's the positive side. Okay? Over here on the right, I made out a little T-chart for us for the first 4 little points, okay? Now, we've got 0, 0. We have 1, 1. We have 4, 2. We have 9, 3. Okay, remember we're taking the square root, so what you look for in your x's for your parent function for some nice easy points to plot out are your perfect squares. Okay, now the 0, 0, that point, we don't necessarily call it the vertex. It essentially is the vertex, but we'll call it the end point. Okay, and you'll notice that and I've made note further along. When you are looking at the table, when you've graphed out a parent function or a square root function, you will notice in the table that past the end point, there's no data, so it gives you an error. That means there's no graph there. Okay, so the graph starts at that end point, and then it may go up and to the right, it may go down and to the right. In certain cases, it may go up and to the left or down and to the left. Okay? Alright, so this goes up, almost looks like at a direct angle from 0 to 1, but then you can see that it exponentially shoots out to the right a lot faster than it's going up. Okay. Let's talk about attributes. Okay. Attributes that we're going to talk about: domain and range, which we've been kind of discussing, the x and the y intercepts, and then the minimum and the maximum on a given interval. Okay. The domain and the range. Excuse me. The domain and the range. You're going to have x is greater than or equal to a number y is greater than or equal to a number, that number is going to come from the endpoint, okay? So whatever our endpoint is, we will use that x and that y in our domain in our range, okay? The x-intercept and y-intercept, of course, is wherever the graph crosses the x or the y-axis. For the parent function that we have here, it's 0 and 0. Now, if you want to write it in the ordered pairs, that's fine. Either way is acceptable. Also, just so that you don't freak out sometime if you're not sure, it is possible for there to be no intercepts. If, let's say, it's a positive graph and it moves up and to the right, then it may never hit the x or the y intercept. Okay, x or y axis, in which case there are no intercepts, and you would just write the empty set symbol with the 0 with the slash through it. Okay. The minimum and the maximum on a given interval. In our little graph up here to illustrate, I gave us an interval of 2 to 6. And I just went and put this into the calculator and let it figure it out for me. I looked on the table, and at 2, I found that my y was at a minimum of 1.414. And at 6, my y was at a maximum of 2.45. Now, one of the things I want you to notice is that between the two interval lines, there's no change of direction. Okay? So that means our minimum and our maximum are going to be found on those outside lines. Okay? So whatever our numbers are in our interval, you can look on your table at those two numbers, and you can find your minimum and maximum. Okay? And this was where I made that note that if you were looking at the table past the endpoint, there would be no data. Okay, let's talk about transformations. We've been through these before. This is nothing new, but I went ahead and wrote them out for you to make sure everybody was on the right page. And I did illustrations, okay? The transformations now we're going to look at the plus or minus a, okay? If a is greater than 1, it's a vertical stretch. We see that in our first equation, y equals 3 times the absolute, or times the square root of x for our vertical stretch, and that's our pink line with the red dots, okay? So that's a wider graph away from the x-axis. The y equals the square root of x in the black and gray, that's our parent function. When a is between 0 and 1, that's a vertical compression. And that's in our green, y equals 1/2 square root x. And that's our green dots and lines. Okay, and then if a is negative, it flips down. Okay, so y equals the negative square root of x was our flip, and that's in our orange. All right, now we are going to take a look at plus or minus b. Okay, the b is inside the square root symbol, the radical symbol, but it's in front of the x, okay? If b is greater than 1, it's a horizontal compression, and this is, I've got an example in the green for the square root of 3x, that's in that green and gold color right there, okay? Again, in the black is our parent function. in this reddish color, and the pink and red dots, pink line and red dots, is the square root of 1/2 x, and 1/2 is between 0 and 1, so that is a horizontal stretch. Okay, and then I gave in purple the example of negative b, which means instead of, we kind of gotten accustomed to things flipping down. This is where we start to see that instead of flipping down, b flips across. This is where we actually get to see that flip from right to left. So negative b flips to the left, and the square root of negative 2x is in purple. Okay, now I made you a note here. If you see y equals the square root of negative x, do not confuse it with y equals the square root of parentheses negative x. Y equals the square root of negative x, not in parentheses, has your negative going with a 1 in front of the x. And that is going to be a negative 1b, and that will flip it to the left. If the negative x is in parentheses, then it puts the number and the negative together, and that gives us a negative number under the radical, which ends up giving us an imaginary number. Alrighty. Now we're going to look at h. Remember, h controls our horizontal movement, left to right. Again, made the note just to remind you that h naturally has a minus sign in front of it. Okay, and then also made a note to remind you that h along with b controls the horizontal movement. Okay, and if it's a plus h, it moves to the right. If it's a minus h, it moves to the left. Or not plus h. If it's a positive h, it moves to the right. Negative h moves to the left. Okay, if you're not sure if it's positive or negative, go ahead and set bx minus h equal to 0, and then solve for x. Okay, we've got some examples here. In the green, shows a shift to the right. The parent is in black and gray, and then the purple shows a shift to the left. Alrighty. Last transformation is in K. This is our vertical movement up and down. Did make a note here. There is a natural plus sign in front of the K. So if it's plus H or positive H, we will move up from the origin. If it is minus K or negative, it will move down from the origin. So in our examples, you'll see in the red or pinkish kind of red, we see the move up, okay? The parent function in black, and then in the turquoise or aqua color, we see a shift down, okay? That's all the notes I have for you. You have the homework. Get that taken care of, and we will answer any questions tomorrow before we take a homework quiz. Okay? All right, y'all have a great day. I will see you tomorrow. Bye.